Hello. Okay. Um, in this video, we're going to learn about combinations. So the question I'm going to use to illustrate what a combination is this one. If 10 people are running a race and there are different prizes for first, second, and third, in how many ways can the prizes be awarded? Now this is not a combinations question. This is a question of permutations, and I'm going to assume you know about permutations. So if you do know about permutations, this is a fairly straightforward question. There's 10 people to select from, and we're putting them in order, but just we're taking 3 of them. So 10p3, which is 720. So there's 720 orders, or 720 ways for these prizes to be awarded. Now, in order to make this a combinations question, I'm going to change it and say, what if all the prizes are identical or the same? So no matter what position you come in, first, second, and third, you're getting the same prize. Well, let's think of an example or two. So let's say that 10 people running the race. Let's say 3 of the people running the race are Joe, Dave, and Bob. Okay? So these are 3 of these 10. Well, there's 7 others, but I'm just looking at these 3. So let's say one of the orders is Joe, doesn't matter, Dave, and Bob. Okay, so Joe wins, Dave's second, Bob's third. Well, let's also look at the case where Joe still wins, but then Dave and Bob switch orders. So this time Bob beats Dave by a hair. So Bob beats out Dave for second position. Well, in the first question up here, I'll put a line to indicate it's different. In the first part, these were different cases, right? This is different than this because Bob and Dave are getting different prizes. But in the third case, or the second case, if the prizes are the same, because the prizes are the same, these two are the same, right? They're the same because it doesn't matter who comes in second and third, or it doesn't matter if Dave beats Bob or Bob beats Dave, they're both getting the same prize. So this is really the same. And there's actually a few more cases involving Joe, Dave, and Bob that are the same, right? Let's say Dave wins. So Dave's first, and then Joe and Bob. Or Dave's first with Bob and Joe. Or who hasn't come in first yet? Bob. Let's say Bob wins, then Dave, then Joe. Or let's say Bob, Joe, and Dave. So all these cases, 1, 2, 3, 4, 5, 6, these 6 cases are all the same if the prizes are the same. They'd be different if the prizes are different. They're different permutations because they're different orders, but in this case they're the same. And now how many? So there's 6 cases that are identical. And if you recognize this as a permutation, you can actually have calculated this 6 by really you're just doing a permutation of 3 objects, right? This is really just 3 factorial, which is just 6. The reason that there was 6 is because we were just saying there's 6 permutations of these 3 people, Dave, Joe, and Bob. So what we're going to have to do to this number up here is we're going to have to divide it by 6. So 720 divided by 6. The reason we have to divide by 6 is because for every grouping of 3, there's going to be sort of 6 permutations of those 3. So we're going to be counting 6 times too many. So if we divide by 6, we're dividing out all those 6 permutations. So that would just be 120. So there's 120 sort of ways the prizes can be given out. This is what we call a combination. So I'm going to write down the definition and then just sort of briefly explain it. Okay, so here's your definition. A combination, so we're defining the word combination, of n objects taken r at a time is a selection of r objects without regard for order. Okay, so just to explain what this means. So if you recognize, this is very similar to the permutations definition. So a combination of n objects, this is how many objects you have to select from. So how many objects to select from. So in that previous example with the people running the race, there was 10 objects to select from because there was 10 people running. And R is how many objects you are selecting. So in this case, there was 3 objects. So in the previous example, we did a combination of 10 objects taken 3 at a time. And then what makes this different than a permutation is this part in blue, which is why I did it in a different color, without regard for order. So in a combination, the order does not matter. And that's sort of the key point that you want to remember. Order does not matter with a combination. It does matter in a permutation. So just kind of notation. So we see the notation we use for combination. Well, if you remember permutation, we wrote NPR, or sometimes we'd write P bracket NR. Combination is the same thing, except instead of using P, you're going to use a C. So sometimes you write CNR. And just to confuse you, not really just to confuse you, but just for convenience, we actually have another notation. Sometimes with combinations are generally used more frequently than permutations, so we won't write the C, and instead of writing it sort of horizontally, we'll write it vertically. So sometimes you'll see it written this way. Okay, so those all just mean a combination of n objects taken r at a time. And what that is equal to, let's just remind ourselves how we calculated this in the previous question. Remember, where was it? Here, this is how we calculated the permutation. We said 720 divided by 6. Well, how did we get the 720? Remember, the 720 was just the permutation. So the permutation, remember, is n factorial over n minus r factorial. So that's a permutation. But then in this previous example, we had to take our permutation 720 and divide it by 6. And remember that 6 came from here, 3 factorial, and 3 in this case was r, it was the number of people we were taking. So we have to also divide it by r factorial. So that's your combination formula. And then you should recognize your calculator will do this function for you, so you should have a button in your calculator that will perform this quicker.